Please adjust to a comfortable position. We will explore together a stunning discovery at the edge of our solar system. An interstellar visitor that defies understanding is rewriting astronomy textbooks. It was a morning in October 2025. The Harvard Astrophysics Center was brightly lit. Professor Avi Loeb was reviewing an astonishing report. He had just given an interstellar object a score of 6 out of 10. On this 10-point scale, a score of 6 means 60% confidence that this object known as 3I Atlas might not be naturally formed. This rating sent shockwaves through academia. Professor Loeb was the same scholar who first suggested in 2017 that Oumuamua might be from an alien civilization. Now he has set his sights on this new interstellar visitor. As you will see in the following analysis, this rating is not baseless, but a rigorous judgment based on multiple independent observational datasets. 227 observatories worldwide have joined forces, conducting 4,022 precise observations of 3I Atlas. Each observation has deepened this mystery. Data from the James Webb Space Telescope shows that 95% of this object's gaseous coma is carbon dioxide, with only 5% being water vapor. This ratio is 16 times more extreme than that of known comets. An even more astonishing discovery came from the Very Large Telescope in Chile. It detected pure nickel atomic emission lines. In the entire history of astronomical observation, nickel and iron have always appeared together. They formed within the same star, were ejected in the same supernova explosion, condensed within the same cosmic dust. Finding nickel without iron is like finding hydrogen without protons. This violates the fundamental chemistry of the universe. Even more perplexing, as 3I Atlas moved closer to the Sun, the nickel emission rate increased 25-fold in just 1 month. This exponential growth does not match the normal outgassing pattern of a comet. Instead, it resembles the systematic evaporation of some material. On the other side of the Earth, amateur astronomers captured even stranger phenomena. Michael Yeager and Gerald Raymond in Namibia, using the dark background of a total lunar eclipse, photographed 3I Atlas glowing bright green, with a bluish tint. Yet just weeks earlier, observations from the Kitt Peak Observatory indicated this object was severely deficient in diatomic carbon molecules, the very molecules that typically give comets their green color. The sudden color change might be related to cyanide. The Very Large Telescope detected a sharp rise in hydrogen cyanide emissions, increasing steeply as 3I Atlas approached the Sun. This growth curve mirrors the nickel emissions exactly, hinting at some intrinsic connection. Orbital dynamics calculations presented an even greater puzzle. Although 3I Atlas ejects 129 kilograms of carbon dioxide per second, along with 6.6 kilograms of water vapor and 14 kilograms of carbon monoxide, its trajectory shows almost no deviation from a pure gravity-driven path. This anomaly can only be explained by an immense mass. Researchers calculated its mass to be at least 33 billion tons, with a core diameter potentially exceeding 5 kilometers. This size is statistically almost impossible. Based on our understanding of interstellar space, we should have discovered approximately 100,000 smaller interstellar objects before finding one as massive as 3I Atlas. But to date we have only confirmed 2 interstellar visitors. Both were far smaller than 3I Atlas. High-resolution images taken by the Hubble Space Telescope on July 21 revealed another anomaly: a teardrop-shaped dust cocoon, with its glow pointing towards the Sun. This completely contradicts the basic physics of comets. Comet tails should always point away from the Sun, pushed by solar wind and radiation pressure. Yet 3I Atlas exhibited a forward-facing glow. By late August, observations from the Gemini South Telescope showed it had developed a traditional anti-solar tail. Within this month or so, some change was occurring on this object. Orbital analysis revealed even more thought-provoking details. 3I Atlas is traveling on a retrograde orbit with an inclination of about 175 degrees. Almost perfectly aligned with the ecliptic plane but in reverse. The probability of this geometric coincidence is only 1 in 500. Its trajectory will bring it for close flybys of Mars, Venus, and Jupiter. Like a meticulously planned tour of the solar system. Professor Loeb calculated that a velocity adjustment of just 10 to 15 kilometers per second would be sufficient to significantly alter its orbit. This is impossible for a natural comet. Sublimating ice can only produce velocity changes of about 0.5 kilometers per second at most. But for a technological object with propulsion capabilities, this would be trivial. The timing is even more noteworthy. 3I Atlas will disappear behind the Sun in late September, coinciding perfectly with its most active perihelion passage on October 30th. This 2-month observational blackout period provides perfect cover for any activity that wishes to avoid observation. The global astronomical community is preparing for October 3rd. On that day 3I Atlas will fly past Mars at a distance of 29 million kilometers. The high-rise camera on the Mars Reconnaissance Orbiter will image its nucleus at a resolution of 30 kilometers per pixel. This resolution is sufficient to distinguish the nucleus from its dust cloud and accurately measure its true size. The European Space Agency's Mars Express and Trace Gas Orbiter will also observe simultaneously, using spectrometers and particle sensors to analyze its composition. These instruments have an unpublicized secondary mission to scan the space ahead of 3I Atlas, searching for possible precursor probes. Because theoretical calculations suggest, if 3I Atlas deployed scout probes ahead of itself, those probes could be heading towards Mars, while Earth-based telescopes cannot detect objects smaller than 100 meters at Martian distances. The entire scientific community is contemplating one possibility. If this is an interstellar reconnaissance mission, its design is perfect. Flying along the planetary orbital plane, making close flybys of multiple planets, hiding at the most observationally valuable moment, arriving just as all detection capabilities are in place. When 3I Atlas re-emerges in early December, telescopes worldwide will be aimed at it, observing whether its orbit has changed. Its activity is different. Its structure is intact. Any anomaly will provide crucial evidence. The Jupiter flyby in March 2026 will be another critical moment. If its trajectory changes in ways unexplainable by gravity, it would imply a non-natural power source. We are now at a key juncture in history. Every observation could bring a groundbreaking discovery. 3I Atlas is either the most peculiar natural celestial body discovered to date, or humanity's first contact with extraterrestrial technology. In the following content, we will delve into every scientific detail, analyze every possibility, explore all dimensions of this interstellar puzzle. Regardless of the truth, we are about to witness a new chapter in astronomy. This universe is more mysterious than we imagined. Each new discovery expands the boundaries of our knowledge. 3I Atlas is leading us to the very frontier of scientific exploration. Let us now start with the most basic chemical signatures, and gradually delve into this captivating scientific detective story. Every data point is a clue. Every anomaly is a signpost, guiding us toward the ultimate truth. Observations from the James Webb Space Telescope on August 6 utilized its near-infrared spectrograph to analyze the gas composition of 3I Atlas. The data revealed an overwhelming dominance of carbon dioxide, with an unusually low proportion of water vapor. Within our solar system, all comets studied are rich in water ice. This reflects the environmental conditions of their formation. In the outer Kuiper belt and Oort cloud of the solar system, water ice is the most abundant volatile substance. While carbon dioxide is present, it usually plays a secondary role. The anomalous composition of 3I Atlas indicates it formed in a drastically different environment, possibly around a star with a different chemical composition, within a protoplanetary disk with unique temperature and pressure conditions. Martin Cordiner, the principal investigator for the Webb observations, noted, "This is among the highest carbon dioxide to water ratios ever measured in any comet. Not just unusual, but unprecedented. The chemical picture grew more complex. Webb also detected significant carbon monoxide and carbonyl sulfide. The combination of these compounds suggests a formation environment of extreme cold, potentially colder than the outermost regions of our solar system. Some researchers believe 3I Atlas might have originated in a molecular cloud region, or been ejected from a planetary system much farther from its star than our own Kuiper belt. The color changes documented by amateur astronomers in July and early August added a new layer to this chemical puzzle. Observations showed 3I Atlas had a reddish coma. This color typically indicates the presence of organic compounds, complex carbon molecules that absorb blue light and reflect red light, standard for comets. But during the total lunar eclipse on September 7th, images showed it glowing bright green, with a bluish tint. Green comets are not actually rare. The color comes from diatomic carbon molecules in the coma, absorbing ultraviolet sunlight and emitting green light. The contradiction lies in the fact that astronomers from Kitt Peak Observatory had already analyzed 3I Atlas in August, finding it to be one of the most decarbon-deficient comets known, extremely lacking in the exact molecules that produce the green glow. So how does a comet with almost no diatomic carbon suddenly emit a bright green glow? Avi Loeb suggested the color change might be linked to the surge in cyanide production detected by the VLT. Cyanide can also produce a greenish color under certain conditions. But this raises another question. Why is cyanide production increasing so dramatically? VLT observations showed hydrogen cyanide emissions rising steeply as 3I Atlas approached the Sun. The production rate wasn't the gradual increase seen with normal cometary outgassing. It was exponential, as if some material was undergoing accelerated thermal processing. Stephanie Miller from NASA's Goddard Space Flight Center, who worked on the Webb observations, proposed that 3I Atlas might have a cooked crust. Billions of years traveling through interstellar space, exposed to cosmic rays and stellar radiation, could have chemically altered its surface layers. Carbon dioxide ices might have been created or concentrated through these processes, giving it unusual surface chemistry. This explanation is plausible. We have never studied an object this old. 7 billion years is older than our entire solar system. Who knows what happens to ice over that timescale? In the near absolute zero void between stars. But this cannot explain all the anomalies. The nickel without iron signature isn't explained by surface processing. Nor is the lack of non-gravitational acceleration despite massive outgassing. Individually, each anomaly might find a natural explanation. But when combined, they form a pattern that is increasingly difficult to dismiss. SphereX observations added to the confusion. It saw 3I Atlas as a point source in the infrared. No extended emission, no coma, no tail, just a dot. Infrared telescopes should see through dust to the thermal emission from warming ice and rock. SphereX should have seen a large, diffuse glow from CO2 ice sublimating across the surface. Instead, it saw a concentrated point of infrared emission, consistent with a relatively compact solid object. This observation contradicts the Comet model, or suggests the object has very unusual thermal properties. Perhaps the surface is highly reflective, bouncing sunlight away before it can heat the interior. Perhaps there's an insulating layer preventing heat penetration. Perhaps the nucleus is spinning so fast that thermal energy distributes before causing significant sublimation. Or perhaps it's not outgassing the way we think it is. Perhaps what we're interpreting as sublimation is something else entirely. The chemical data also reveals information about 3I Atlas's possible origin. The low metallicity, the high hydrogen and ice content, suggests it came from a region of the galaxy where star formation happened early. The Milky Way's thick disk, populated by older stars with less heavy element enrichment. Models place its origin somewhere between 7 and 11 billion years ago, making it a relic from an epoch when our galaxy was very different. If 3I Atlas is natural, it is a time capsule from the ancient galaxy. A chunk of primordial ice carrying chemical signatures from billions of years before Earth existed. That alone would make it the most scientifically valuable object we've ever observed. But the chemistry keeps not quite fitting. The CO2 dominance is explainable. The lack of water is explainable. The cyanide is explainable. The color change is explainable. Individually, each piece has a potential natural explanation. That requires stretching our models slightly but not breaking them. What's troubling is the combination. It's the pattern of all anomalies appearing in the same object. It's the statistical improbability of this specific set of characteristics occurring together by chance. November and December will bring more data. When 3I Atlas re-emerges from behind the Sun, ground-based telescopes will capture fresh spectra. More emission lines. More chemical signatures. More constraints on composition. And by comparing pre- and post-perihelion chemistry, we will learn whether solar heating changed anything fundamental about this object's behavior. The highest resolution image of 3I Atlas, captured by the Hubble Space Telescope on July 21, 2025, showed something that violated basic comet physics. The image revealed a teardrop-shaped dust cocoon. But the glow was elongated ahead of the object, toward the Sun. There was no distinct tail streaming behind it in the anti-solar direction. This is backwards. Comet tails are pushed away from the Sun by solar wind and radiation pressure. Tails should always point away from the Sun, creating the classic swept-back appearance we associate with comets. But 3I Atlas had its bright side facing forward, toward the Sun, with no obvious tail behind it. Avi Loeb and his colleague Eric Keto published the only paper in the scientific literature attempting to explain this anti-tail. They suggested the forward glow might be dust particles being pushed ahead of the nucleus by some internal process. But even they admitted this was speculative. There's no clear mechanism that would create a forward-pointing dust cloud on a natural comet. Other astronomers dismissed the observation entirely. They claimed the glow wasn't an anti-tail at all, just smearing from Hubble's tracking of the fast-moving object. The telescope was following 3I Atlas as it moved through space, causing background stars to streak in the exposure. Maybe the forward glow is an artifact of that tracking motion. But Hubble's image processing teams know how to account for tracking effects. The streaked stars are obvious in the image. The forward glow is not a streak. It is a distinct region of enhanced brightness with defined structure. If it was just a tracking artifact, it should look like the stellar trails. It doesn't. Then in late August, the Gemini South Telescope captured new images using its multi-object spectrograph. And suddenly 3I Atlas had developed a proper tail. A faint, teardrop-shaped tail in the anti-solar direction behind the object. Exactly where comet tails are supposed to be. So between July 21 and August 27, something changed. Either the object started behaving more like a normal comet, or our viewing geometry shifted enough to reveal what was always there but obscured by the dust cloud. The July Hubble image was taken when 3I Atlas was about 4 astronomical units from the Sun. The August Gemini image was at roughly $2.60. Closer to the Sun means more solar heating, more outgassing, potentially more dust production. It's plausible that the tail simply hadn't developed yet in July and appeared later as activity increased. But that doesn't explain the forward glow. Normal comets don't have bright halos pointing toward the Sun. They have comas, spherical clouds of gas and dust surrounding the nucleus. The coma can be brighter on the sunward side because that's where sublimation is most active. But it shouldn't create a directional glow ahead of the object's motion. Another puzzling detail in the Hubble image. The dust cocoon extends about 3,000 kilometers on all sides of 3I Atlas. Loeb calculated that if the nucleus is 10 kilometers in diameter, the dust density at 3,000 kilometers out would be diluted by a factor of 90,000 compared to its density near the surface. That's a huge drop-off. For that diluted dust to still be bright enough for Hubble to detect, either there's an enormous amount of dust being produced, or the dust particles are exceptionally reflective, or something about the scattering geometry is unusual. The Gemini images also showed color variations. Different wavelength filters revealed different structures. In ultraviolet, the object appeared more compact. In red and infrared, the dust cloud was more extended. This is consistent with normal dust scattering properties. where smaller dust particles scatter blue light more efficiently, and larger particles scatter red light. But it also means the dust grain size distribution is not uniform. There's a population of very small particles close to the nucleus, and larger particles farther out. This distribution pattern could tell us about how the dust is being ejected. Fast-moving small particles, slower-moving large particles, classic. Except the rotation period complicates things. Observations showed 3I Atlas rotating once every 16 hours. That's relatively slow for a small object. A 10 km nucleus rotating every 16 hours has a surface velocity of only about 1 m per second at the equator. That's not fast enough to fling dust particles into space through centrifugal force. So the dust must be ejected by gas pressure from sublimation. Carbon dioxide subliming from the sunward side carries dust grains with it. But analysis of the Hubble image suggested dust particles were moving at about 20 m per second. That's much faster than the rotation speed, but consistent with gas drag from sublimation. Here's where it gets interesting. If dust is being ejected at 20 meters per second by CO2 outgassing, and if the object is losing 129 kilograms per second of CO2 as Webb measured, then the dust production rate should be substantial, probably tons per second. That much dust should create a very obvious tail. A bright, extended tail visible in professional telescope images. But the July Hubble image didn't show one. Only the forward glow and a diffuse coma. One possibility is that the dust particles are so small. They're being pushed forward by radiation pressure before they can form a traditional tail. Radiation pressure from sunlight can accelerate tiny dust grains faster than gravity pulls them toward the sun. If the dust grain size is less than a micron, radiation pressure dominates. And the particles could be pushed ahead of the nucleus. But that would create a forward tail, not a forward glow. The morphology is wrong. Another possibility is that the dust is being electrically charged by solar ultraviolet radiation and interacting with the sun's magnetic field. Charged dust behaves differently than neutral dust. It can be focused or dispersed by magnetic fields in ways that create unusual shapes. NASA's Sphere X observation adds to the confusion. It saw 3I Atlas as a point source in the infrared. No extended emission, no coma, no tail, just a dot. But Hubble clearly saw extended structure. The difference is wavelength. Hubble observed invisible light, Sphere X in infrared. Dust reflects visible light but emits thermal infrared based on temperature. If the dust around 3I Atlas is very cold, colder than expected for that distance from the sun, it would be dim in the infrared, even if bright invisible light. That suggests the dust isn't being efficiently heated by sunlight. Maybe it's highly reflective, bouncing light away before absorbing heat. Maybe it's composed of materials with unusual thermal properties. The tail situation will become clearer in December, when 3I Atlas emerges from behind the sun. Fresh observations from multiple telescopes at multiple wavelengths will show whether the tail developed further, whether it matches normal cometary tails, or whether it's still showing unusual characteristics that don't fit the models. 3I Atlas is traveling on a retrograde orbit inclined at roughly 175 degrees to the ecliptic plane. That sounds extreme, but here's what it exactly means. The object is moving almost exactly on the plane of the planets, just backward. It's threading through the solar system along the same flat disk where Earth, Mars, Venus, and Jupiter orbit, the opposite direction. The probability of that happening randomly, 1 in 500. Most objects entering the solar system from interstellar space should come from random directions. Space is three-dimensional, there's no preferred orientation. If interstellar comets are just debris ejected from other star systems on random trajectories, they should arrive from all angles, some from above the ecliptic plane, some from below, some from the sides, uniformly distributed across the celestial sphere. But 3I Atlas came in almost perfectly aligned with the planetary orbits, just 5 degrees off from the ecliptic plane. That's not impossible, but it's highly improbable. And it's not just the inclination. The trajectory brings 3I Atlas close to multiple planets. It passes within 30 million kilometers of Mars on October 3rd. It will pass within reasonable proximity to Venus. And in March 2026, it approaches within 54 million kilometers of Jupiter. Each individual close approach isn't remarkable. Space is big, lots of orbits pass near planets without being deliberately aimed. But the combination, the alignment with the ecliptic plus multiple planetary encounters, reduces the probability significantly. Loeb calculated that the combined odds of all these geometric factors occurring by chance is roughly 1 in 500. Not impossible, but suspicious enough to warrant consideration of non-standard explanations. If 3I Atlas was deliberately sent to survey the inner solar system, you'd want a trajectory that passes near the major planets. You'd want to align with the ecliptic plane, because that's where the interesting stuff is happening. All the rocky planets, most of the moons, the asteroid belt, the regions where life could potentially exist. A surveyor probe would naturally follow this geometry. Critics argue this is selection bias. We're only noticing 3I Atlas because it came close enough to detect. There might be hundreds of interstellar objects passing through the solar system on random trajectories that we never see because they're too far away and too faint. The ones we detect are necessarily the ones that came close to the Sun and Earth. That's valid. Our detection capability is heavily biased toward objects that pass through the inner solar system where our telescopes are concentrated. We might be missing the vast majority of interstellar visitors that stay in the outer regions. But it doesn't explain the specific alignment. Even among objects that pass close to the Sun, most wouldn't be aligned with the ecliptic. Most would have high inclinations, diving through the planetary plane at steep angles. The fact that 3I Atlas is nearly coplanar with the planets is unusual. Even within the subset we'd be capable of detecting. There's another aspect of the trajectory that's interesting. 3I Atlas is on a hyperbolic orbit with an eccentricity of about 6.16. That means it's moving well above escape velocity. It's not gravitationally bound to the Sun, it came from interstellar space, and it's returning to interstellar space. But by running the orbital mechanics in reverse, astronomers can calculate where 3I Atlas came from. Originally, the calculations suggested origin somewhere in the thick disk region of the Milky Way. Possibly from a star system 7 to 11 billion years old. That's incredibly ancient, older than our Sun, older than our solar system. If 3I Atlas formed around a star that old, it's been traveling through space for potentially billions of years. The cosmic radiation exposure, the chemical alterations, the sheer age of the object, makes it unlike anything we've studied before. The path through the galaxy also tells us something. At its current velocity, minus the gravitational acceleration from the Sun, 3I Atlas was traveling at about 58 kilometers per second through interstellar space before entering our system. That's typical for objects in the thick disk population. The velocity matches expectations. What doesn't match is the arrival timing. 3I Atlas entered the inner solar system in mid-2025. Just as our detection capabilities reached the point where we could spot it. The Vera Rubin Observatory came online. Atlas reached full operational status, SphereX launched. All the infrastructure needed to characterize an interstellar visitor was in place. Is that coincidence, or is it timing? If an advanced civilization wanted to send a probe to survey our system, they might choose their arrival time strategically. Wait until the target civilization has developed enough technology to detect and study the probe. Arrive when telescopes exist that can characterize composition and measure trajectories. Make first contact when the recipients are capable of understanding what they're seeing. That sounds like science fiction, but it's not impossible. Any civilization capable of interstellar travel would likely be capable of observing target systems from a distance. They could watch for technological signatures, radio transmissions, artificial lighting, atmospheric pollution. Signs that a civilization has reached a certain development threshold. Earth has been broadcasting radio signals for over a century. Our technology signatures have been visible to external observers for decades. If 3I Atlas was sent in response to detecting those signatures, the timing would make sense. Of course, this requires accepting that interstellar travel is feasible. That some civilization figured out how to send objects across light years of space. That they chose to send one here. That they disguised it as a comet. That's a lot of assumptions. But the trajectory remains, 1 in 500 odds, perfectly aligned with the planetary plane. Close approaches to multiple worlds. Arriving exactly when we developed the capability to study it properly. The March 2026 encounter with Jupiter will be telling. If 3I Atlas maintains its predicted trajectory, passing Jupiter at the expected distance with no deviations, that supports the natural explanation. Orbits governed purely by gravity are predictable, no surprises. But if there are deviations, if the trajectory changes in ways that can't be explained by gravitational perturbations from the planet, then we have a problem. Then we need to explain what altered the course. And natural explanations run out quickly once you eliminate gravity and outgassing. October 3, 2025. That's tomorrow. The high-rise camera aboard the Mars Reconnaissance Orbiter will point toward 3I Atlas as it passes 29 million kilometers away. 30 kilometers per pixel resolution. Detailed enough to separate the nucleus from its dust cloud. Detailed enough to measure surface area and constrain the actual size of this thing. If the nucleus is confirmed at 5 kilometers or larger, the statistical problem becomes impossible to ignore. We should have found thousands of smaller interstellar objects before detecting one this massive. The natural explanation requires increasingly contrived coincidences. ESA's Mars Express and ExoMars Trace Gas Orbiter will observe simultaneously. Using spectrometers and cameras, multiple wavelengths, multiple instruments, multiple perspectives. Between all the Mars spacecraft, we'll get the most detailed look at an interstellar object ever captured by humanity. And we'll search for precursor probes. Objects traveling ahead of 3I Atlas that could reach Mars. While we're watching the main body, HiRISE will scan the surrounding space. If anything shows up that shouldn't be there, if multiple objects appear instead of one, the conversation changes immediately. Then comes the waiting period. 3I Atlas disappears behind the Sun from Earth's perspective in late September. We lose line of sight. The object reaches perihelion on October 30th, its closest approach to the Sun. Hidden from our telescopes by 150 million kilometers of incandescent plasma. 2 months of blindness. 2 months where anything could happen and we wouldn't see it. Trajectory adjustments, probe deployments, fragmentation. Whatever occurs during that window, we'll only learn about it in December when the object emerges. December 3rd is when ground-based telescopes expect to reacquire 3I Atlas. Amateur astronomers around the world are preparing. Professional observatories are scheduling time. Everyone wants first light on the object coming back from perihelion. And everyone will be comparing the post-perihelion observations to pre-perihelion data. Has the brightness changed? Has the outgassing increased or decreased? Most importantly, is it where calculations predict it should be? If 3I Atlas emerges on a different trajectory, if its orbit has changed in ways that can't be explained by gravitational interactions with the Sun and planets, that's evidence of propulsion. That's evidence of technology. That's when even the skeptics will have to consider alternatives. The chemistry will tell us more, too. Fresh spectroscopy in December will show whether the nickel without iron signature persists, whether the carbon dioxide dominance continues, whether new emission lines appear that weren't present before perihelion. Thermal processing from solar heating might alter surface chemistry in detectable ways. If the object fragments, that actually supports the natural comet hypothesis. Natural comets sometimes break apart near perihelion from thermal stress. We've watched it happen with comets like Shoemaker-Levy 9 before it impacted Jupiter. Fragmentation would be normal. Unless the fragmentation looks controlled. Unless multiple pieces separate cleanly and head toward different destinations. Then fragmentation becomes deployment. March 2026 brings the Jupiter encounter. NASA's Juno spacecraft, currently in polar orbit around Jupiter, could potentially observe 3I Atlas as it passes within 54 million kilometers. Juno has cameras, spectrometers, particle detectors. Instruments designed to study Jupiter but capable of characterizing this visitor. There's been discussion about whether Juno could maneuver for a closer look. The spacecraft has limited fuel and a planned end of mission. Using that fuel to chase an interstellar object instead of studying Jupiter would be controversial. But if the October and December observations reveal something truly anomalous, the scientific case for redirecting Juno becomes compelling. ESA's JUICE spacecraft will also attempt observations in November. though we won't receive that data until February 2026 due to communication delays. JUICE is farther from Earth, on the opposite side of the Sun, using its antenna as a heat shield. Data transmission is limited until it adjusts orientation. So we're collecting observations across multiple months. From multiple spacecraft at multiple locations in the solar system. By spring 2026, we'll have the most comprehensive dataset ever assembled for an interstellar object. And that dataset will either confirm 3I Atlas as an exotic but natural comet from another star system, or it will force us to seriously consider that we're being visited. The scientific community is preparing for both possibilities. Privately, astronomers are discussing what the protocols would be if technological signatures are confirmed. Who announces it? How do you verify extraordinary claims before going public? What are the implications for planetary defense if more objects follow? There's no established procedure because nobody seriously expected this scenario. SETI protocols focus on radio signals and intentional beacons, not physical objects masquerading as comets. The closest analog is the procedures for announcing discovery of life on Mars or Europa. Careful verification, peer review, multiple independent confirmations before any public statement. But those procedures assume months or years of analysis time. 3I Atlas is moving through and leaving the solar system. If we're going to study it properly, decisions need to happen quickly. Some scientists are advocating for an intercept mission. Launch a small probe to rendezvous with 3I Atlas before it escapes beyond the orbit of Jupiter. Get high-resolution images, sample the outgassing plume. Measure magnetic fields and particle emissions up close. The problem is timing. Even a fast spacecraft would take months to catch up. By the time authorization and funding came through, by the time the probe was built and launched, 3I Atlas would be long gone. Interstellar objects move fast, opportunities are measured in weeks, not years. That's what makes this October to March window so critical. This is our chance, our only chance, to gather data on the third confirmed interstellar visitor, before it vanishes back into the void between stars. After March, it'll be too far away and too faint for detailed observations. We'll watch it fade into the distance. Extract every bit of information possible from the observations we manage to collect. And then wait. Wait to see if our analysis reveals natural explanations for all the anomalies. Wait to see if more interstellar objects arrive with similar characteristics. Wait to see if the statistical problem resolves or compounds. And we'll wonder. Even if the data ultimately supports a natural origin. Even if every anomaly finds a conventional explanation. We will wonder. Because 60% probability of technology means 40% probability of natural. And 40% isn't zero. The universe has surprised us before. Black holes, dark energy, exoplanets, gravitational waves. Each discovery revealed phenomena we didn't predict and barely understand. 3I Atlas might be another surprise. Something natural but so unusual, so unexpected, that it challenges our models and forces us to expand our understanding of what's possible. Or it might be the biggest discovery in human history. First confirmed contact with technology from beyond Earth. Evidence that we're not alone. Proof that other civilizations exist, and some of them achieve interstellar capability. We will know soon. The dates are coming. October 3, 2025. December 3, 2025. March 2026. 3 dates that might change everything. As you watch this video, scientific teams worldwide are working intensively. Analyzing data, verifying theories, preparing observations. We are standing on the threshold of history. Possibly discovering that humanity is not alone in the universe. Or discovering a completely new natural phenomenon. Regardless of the outcome. This journey of exploration has already changed us forever. It reminds us that the universe is still full of wonders. And that science is humanity's most powerful tool for understanding those wonders. Please stay tuned. Because the truth is out there, waiting to be revealed.